Hello. It's exactly 40 years since I started doing databases in a serious way. So the year 2020 and 2020 vision was really too hard a wordplay to resist. So this talk is a bit of a retrospective in which I want to draw on the experience of those 40 years to point out that, although the technology has changed drastically, we still need to apply the same sort of thinking today that we did 4 decades ago. 40 years ago, I started developing Minark, a flexible database manager for archaeology. Databases were at that time one of the main topics at CAA. They were heady days when databanks were going to solve all our problems. Interestingly, I think we're starting to see some of those ideas come back in a more realistic fashion in the form of linked open data. Minark was a more modest idea, used by a number of state Aboriginal and historic site registers at the time, by excavations such as the Hyde Park Barracks, and for quite a number of personal research projects. One of the drivers for creating Minark was the lack of approachable tools for digital data recording or management at the time. The first spreadsheet, VisiCalc, came out on the Apple II in 1979, and they really didn't become widely available until the mid-1980s. For databases, you had DBase II, which needed programming for all but the most basic operations. Beyond that, everything had to be coded. As a result, there were a lot of write-only databases. People would say, "We've entered all the data, but we're still waiting for the programmers to give us a printout." I'm really not exaggerating. My 2020 vision at the time was that archaeologists needed a way of setting up their own databases, which they could manage themselves without the need for programmers, or indeed the need to develop the orthogonal technical skills required to design and build databases. At the time, therefore, what was needed was a system which was easy to configure, could be easily modified as the user's needs evolved, would immediately give you the ability to filter, create printouts, and do some simple analysis, and to write out subsets of the database to feed into other programs, such as SPSS at the time. Minark didn't try to do everything. It aimed to record and manage data in a structured way. It was basically flat file, easily modified with multi-value fields and enumerated drop-downs. No media files, no relationships, a plain workaday tool of its time. People liked it for that. By 1997, when I made the last updates to Minark, my 2020 vision extended well beyond the flat file concept of Minark to a more richly related set of entities. But I didn't really have the programming skills to build such a system, nor in fact the time. Besides, commercial offerings such as FileMaker and Access, MapInfo for mapping and later ArcGIS, seemed to offer a lot more bang for the buck than flogging a dead, or at least rather aging, horse. 40 years after starting Minark, I am 15 years into developing Heurist, a flexible database manager which follows the same basic philosophy. Flexibility to set up and evolve the structure of the database, end-user control without programming, filtering, reporting, and data exploration. The scope has expanded to a broader humanities remit. I don't do the programming anymore, and the technology, of course, has changed. Everything is now web-based and richly connected, multi-user with multimedia and mapping data, sophisticated searching, and the ability to generate websites built in from the start. However, the basic principles are the same. What is important to both these projects is the iterative nature of research. One should be able to get started setting up something very simple and start using it immediately, and not be stuck waiting for stuff to be developed. But, unlike a basic spreadsheet, which is undeniably easy to set up, but then becomes a straitjacket on further development, whatever you use needs to be ready and waiting to support the evolving needs of your project or projects, without the roadblock of having to re-implement the database as your needs grow. It is worth drawing a parallel with research data management planning, which should also reflect this circular, iterative approach to databases, rather than a one-way track to completion and eventual extinction. I think it's very important to think of the databases we create now as something which will go on growing and evolving, or at least remaining useful, not just as an immediate response to short-term need. We also need to be quite explicit that we are likely to need several separate data systems. A bibliographic system to start with, a media management system for photos, scans, videos, 3D models, etc., a database management system for quantitative and descriptive data, that's where Heurist fits in, for instance, and a GIS system for spatial data, if that's your thing. The key to good practice is to think about these systems can be linked together to avoid redundant storage of data, Artifacts in your database, for example, should be able to reference images in your media management system and be rendered in your GIS without lots of copying. The enemy of this 2020 vision is ad hoc and bespoke systems. When I say bespoke, I'm not against adopting a purpose-built tool for a domain, such as a fully developed excavation or museum management system. Build once, use many times is at the heart of my approach. What I mean is a one-off solution for a particular project built either internally or by consultants through programming which serves only that particular project. It's an expensive and dangerous way of proceeding. By the same token, although or because spreadsheets and simple databases are the path of least resistance and can be set up in minutes, they should only be used as a data collection device. When they start to metastasize into a data management tool, you're on your way to a reinvention of the square wheel. We have the technology now to do a whole lot more, and it doesn't need to be expensive, either in the investment of time and effort, nor in cold hard cash, because so much is now available as open source. You might think that with the past decades of frenetic IT progress, from a basic CP/M microcomputer in the 80s with less memory than a supermarket loyalty card, to cloud servers, high-resolution touchscreens, intuitive interfaces, and gigabit connectivity today, there would no longer be a need for systems specific to archaeologists, or indeed to the broader humanities. However, despite new database technologies such as NoSQL and network databases, and online database builders such as Google and Airtable, building databases remains a complex conceptual and indeed technical task, and in fact I would say as much an art as a science. For this reason, apart from getting well-adapted technical solution which can grow with your projects, it's really important not just to try and roll your own, but to get knowledgeable help from domain experts. There are enough people around now who have the experience of managing data, particularly in the CAA community, who will be happy to share their expertise. Let me expand a little bit more on the reason why just building something from scratch doesn't work. There's a world of difference between building a skeleton container consisting of a set of tables and fields or equivalent, such as what you see here, and building a database application which actually knits those data together into a usable system. Building the skeleton might only require a day if you know what you're doing, but building a fully usable application can take months to years, with plenty of opportunities for miscommunication between users and technical staff, and the potential for complete failure. Building a capable database application is beyond the skills or interest of most humanities practitioners, requires costly technical development, places dependency on key personnel, and is costly to maintain going forwards. Here's a quick list of some of the components for a successful database application. The first group are basics. Define the entities and what you want to record about them, create the structures to hold those entities and attributes, and start entering data. But that is just the skeleton. That's really only the easy start of the process. People get fooled by this because it is relatively easy and it feels like you're getting a long way down the track. Depending on the system you are using, however, the items in the second group may be more or less built in, but once you get to the third group and beyond, you're pretty much into having to code all the capabilities from scratch. That's highly technical, costly, and the outcomes are uncertain. Archaeologists have, of course, responded to these issues by developing specific database applications for regionally specific excavation strategies, while the GLAM sector has spawned a number of more or less expensive turnkey systems. Individual digital humanities centers have developed tools initially for internal use, later packaged for more general use. We built Heurist, but that wasn't until 2005. Before that, we built quite a number of more specialized databases, several of which have been since migrated to Heurist, as much for reasons of sustainability and cost of maintenance as to provide new functions. As a very recent example of one of those systems, we built an Excavation Fines database in 1997 for Casey & Lowe, a historical archaeology consulting firm in Sydney that many of you will know. It was built in Access and has since collected the data from 100 archaeological excavations, 17,000 contexts, and 140,000 find lots. The main find lots table has 108 fields, and there are about 45 other tables, plus some other databases for specialist studies on the side. As you can see, it's a fairly complex system. The form for artifacts, actually artifact lots, since it includes things like bags of fragments, is a typical access form with many drop-downs, but the table also has lots of other fields added over the years and populated in various ways. The database has been used quite successfully over nearly a quarter of a century, but evolving needs have seen new fields and tables added, so that it has become too complex and too dependent on very specific knowledge of key individuals, a very common problem. The IT consultant who kept it running retired last year. They reached the sustainability cliff. So earlier this year, we rebuilt the database for them in Heurist. The structure is fairly simple, although the number of fields made it somewhat tedious, but it only took a few days to set up the structure. Migrating the data was more challenging, as we did forensics on the fields to discover the meaning of things that people, particularly people who'd moved on, had added for specific purposes and resolving inconsistencies. This is a database of uncommon scope. Few projects could claim a database continuously used and extended on this scale for such a long period. It's a great achievement. In fact, as a result, I was nervous about undertaking this job because of the long-term support needs of a consultancy firm, which we really aren't set up to handle. Fortunately, we were able to do this in collaboration with a Sydney-based IT company, Systemic Solutions, who specialize in government databases and website migration, but also have an academic sideline. They've taken on the coordination, maintenance, and ongoing support for the project. We're also working with New South Wales Intersect on another project where we've done the database design, setup, and training, the fun bits for me, and they are doing the less glamorous work of cleaning up and loading data from third-party sources. These two projects seem to be good examples of the potential of industry partnerships, while noting that in both cases it is not simply contracting the job to an outside agency, which I would advise against unless they have relevant domain experience and a good track record, but building on specific academic expertise with the support of IT industry partners. The other area where people often go out to external consultants is the creation of websites. This has been a huge change over the last decade. My experience of picking up the pieces is that most commercial web developers have very little idea about humanities content. So while they may produce a nice project website, often at a rather steep price, things get sticky when they start trying to embed data, both at the conceptual level of why it is there and how it should be presented, and at the technical level of building connectivity between a website and data sources. It's one of the reasons we've built a CMS directly into Heurist, so we can repurpose the widgets from which Heurist's interface is built into widgets in the web pages and directly publish the results of queries, mapping, network diagrams, etc. as native components of the website. This particular website presents information to accompany a distributed exhibition for Matthew Spriggs's laureate project and was put together in a couple of days. It allows navigation by maps of find spots, which I haven't included in the presentation. I think it's also worth mentioning at this point the FAIR principles, findable, accessible, interoperable, and reusable data, which are increasingly become a guiding principle for project data. It's a long road from the spreadsheet on your desktop to making FAIR data. You need to use metadata standards and well-established vocabularies, generate specific non-trivial formats, publish metadata to the right places, handle external access, and so forth. If you use a well-established server-based tool that feeds into other systems, the effort of making data fair will probably already have been done. Or if it's not, it's a cost which can be shared across all users. The whole is greater than the sum of its parts. And with a nod to the previous paper, building on established systems opens up new pathways. The two images at the bottom right are screens of a FAMES tablet application which was built automatically from a Heurist database. No extra work was involved. I'll finish with a couple of quotes from Torsten Madsen in the 2000 CAA proceedings, which put so clearly the reasons for building what you do on top of existing domain-friendly systems, which are flexible enough to conform to your specific needs. The key take-home is that, when thinking about present needs, you should really be thinking beyond those to the long-term implications, ongoing costs, maintenance, archiving, and reusability of what you're creating. If it is worth doing in the first place, it is worth doing properly.